Hello, in this video we will explain normal random variables. So what is a normal random variable? So if a random variable follows this expression for its probability density function, then we call this is a normal random variable or normally distributed with the parameters mu and sigma square. So this is sigma square. So we can write this random variable follows n, which means normal, and with the mu and sigma square, these two parameters. So mu is the mean of this random variable and sigma square is the variance of this random variable. And the probability density function is square root of 2 times pi. Then outside of this square root, we multiply with sigma. Then sigma is the standard deviation, or sigma square is the variance. Then this factor times the e, which is the scalar number 2.718, and with a power minus x minus mu, then take a square, then divided by 2 times sigma square. So this random variable has the availability of the values between negative infinite to the positive infinite. So this probability density curve is the normal random variables density curve. So under this curve, the area will be 1. And each point on this curve is the probability density associated with random variable x. Or this random variable's value, we can also say this is the quantile value. So for example, we are interested in the blue area, which is the cumulative probability for this random variable less than minus x. So here x is a positive number. And this blue area is also with the same area as this blue one. So this is the probability of random number in this distribution larger than x. So you can see the normal random variables density curve is symmetric. And we also call this is a bell shape. So here we have seen that the mu, this parameter is the mean value of normal distribution. So here mean value is mean, but not necessarily zero. This is the mean value. And the variance of random variable is sigma square. And very important in normal random variable is that if we want to calculate the probability of this random variable with parameter mu and sigma, then usually we can transform this value to a z value. So this is also called standardization, because we use the random variable minus its mean value, then divided by its standard deviation. So this z value follows a normal distribution with mean equals 0 and variance equals 1 after we have transformed this normal random variable. So this z value follows so-called standard normal distribution. So this is the cumulative probability expression for this z number. So here we also just use small letter x. So this is the standard normal distribution random variables cumulative probability which is the integral from negative infinite to this quantile value. Then take integral over dy. So we use this is phi x, so which means the cumulative probability. If we look at this figure, this is the same as, for example, this blue area, or we can say this is the cumulative probability to x, so which is this blue area plus this white area. So this phi x is very useful because if we want to calculate the random variable x between a and b's probability, because x follows this normal distribution with mu and sigma square, then this probability is the same as phi b minus mu divided by sigma, then minus phi a minus mu divided by sigma. And we have said that if we want to calculate the cumulative probability of x less than b in this original normal density curve, then we can calculate the same as the probability of phi, which is the standard normal distribution's cumulative probability of this value after transformation. Then we take a look at an example. If x is a normal random variable with mean mu equals 3 and the variance equals to 16, then try to find probability of x less than 11. Second is larger than minus 1, and the third is between 2 and 7. Then, following the previous methods for the transformation to standard normal distribution, so for the first problem, p of x less than 11, which is same as the phi 2, because x minus 3 less than 11 minus 3 divided by 4 equals 2. So which is same as to say we want to calculate the cumulative probability of up to 2 in a standard normal distribution. So equals 0.9772. Second problem is larger than minus 1, which is this value larger than transformed to standard normal random variable, and this is minus 1 in z value also. So x larger than minus 1, same as probability of z larger than minus 1. And z minus 1 actually is same as probability of z less than positive of this number 1. Because the probability is symmetric, right? So the result is 0.84. And the third problem of x between 2 and 7 is same as this transformed random variable between these two numbers. Actually is phi 1 minus phi minus 1 of 4. And for the second term, phi minus 1 of 4 is same as 1 minus phi of 1 of 4. So actually is this result of 0.44. Thanks for watching.